In the bitter winter of 1943, the North Sea was a gray expanse of ice, fog, and jagged waves. The Kriegsmarine patrolled cautiously, wary of the invisible threat that the Allies had perfected: aircraft, submarines, and now rumors of a weapon no one had yet witnessed. It began with intercepted intelligence. German codebreakers noted an unusual pattern of radio silence from ports along the British coast. Ships that should have been in harbor vanished, replaced by reports of enormous flashes at night. Tremors felt miles away, and the occasional column of smoke erupting from nowhere. At first, commanders dismissed it as propaganda. No naval gun in history could fire with that range, that accuracy, and that destructive power. Yet, in February 1944, a reconnaissance sortie over Scapa Flow confirmed their worst fears: massive barrel emplacements, camouflaged beneath reinforced concrete, pointing out toward open sea. The Allies had constructed something so formidable, the Germans had assumed it was myth. Lieutenant Karl Hoffmann, stationed at a coastal observation post in Norway, was one of the first to witness the weapon in action. On a foggy night, the horizon lit up with a single, blinding flash. A massive shell traced an impossibly straight arc, landing miles away on a German convoy without warning. Survivors described it as a thunderclap from the heavens. Every telescope, every rangefinder, every map they had failed to anticipate its trajectory. Reports reached Berlin within hours. The High Command demanded immediate reconnaissance. Engineers were dispatched to survey captured coastal positions. What they discovered was staggering. The barrel alone measured over 60 feet, constructed from a single forged piece of steel. Inside, rifling so precise it could maintain velocity over 40 kilometers. Yet it was not just size that terrified them, it was the mechanism. The breech system was unlike anything German engineers had ever encountered. Instead of conventional hydraulic or manual loading, it used a combination of compressed air and electromagnetic assistance, allowing shells to fire with unprecedented speed and force. Calculations suggested a projectile could reach almost 1,500 meters per second, faster than any round the Kriegsmarine had ever seen. The German Navy attempted countermeasures. Coastal artillery, submarine intercepts, and reconnaissance planes all failed. Every test and measurement confirmed what they had feared. This was not ordinary artillery. It was a weapon designed to dominate, to control the sea from a distance Germany could not match. The first captured fragment, a spent shell casing recovered from a frozen beach near Aberdeen, was analyzed by top metallurgists. Its alloy composition was unusually light, but incredibly strong. Unlike German shells, which relied on sheer mass for destructive power, this casing hinted at a design philosophy Germany had never mastered: precision engineering paired with material science that defied the era's standards. German intelligence compiled a dossier, Canon 1944. A hypothetical weapon until now. The truth shattered the imagination of even the most seasoned officers. It could destroy a convoy, breach reinforced hulls, and outrange any German counterpart by nearly 20 kilometers. The Allies had achieved what Germany had only theorized in secret technical manuals. On March 15, 1944, Lieutenant Hoffmann was ordered to witness a demonstration of the weapon in person. From a distant cliff, shrouded in mist, the first shell rose from the horizon. The flash illuminated the fjord in stark, unnatural white. The projectile sailed through the air with terrifying precision, striking a derelict ship target miles away with such force that debris rained down like shrapnel from the sky. Hoffmann later wrote in his journal, "We had known fear, but never like this. It was as if the sea itself had turned against us. Every measure we had, every plan we conceived, was obsolete the moment that gun fired. The weapon was captured, in fragments, by German forces after a coastal raid in early April. Engineers dismantled parts of the breech, the barrel, and the firing mechanisms. But the more they examined it, the more they realized something unnerving. Every component was constructed with tolerances Germany could not replicate. Bolts machined to thousandths of a millimeter, alloys refined to a purity that rivaled anything in German foundries, and mechanical systems so synchronized it appeared almost alive. The Germans tried reverse engineering it in secret bunkers, but failure after failure followed. Every attempt to fire a prototype resulted in catastrophic misfires. Barrels cracked, breech mechanisms exploded, and the few surviving engineers spoke of strange vibrations in the metal, almost as it resisted their manipulations. By May, reports were clear. The weapon was beyond their comprehension. It wasn't just the size, the velocity, or the engineering. It was the philosophy behind it, a combination of material science, mechanical precision, and scientific foresight that Germany had dismissed as impossible. High Command acknowledged the grim truth. This weapon, if deployed fully, could alter the balance of naval power in the Atlantic and North Sea. And yet, Germany neither replicate it nor counter it effectively. The war was shifting, silently but decisively. Even after the fragments were transported to secret facilities in Kiel and Lübeck, German engineers continued to encounter anomalies. Instruments measured forces they could not calculate. Magnetic fields fluctuated inside the barrel. The remaining shells were heavier than expected, yet discharged faster than physics should allow. Some whispered that it was almost intelligent. The Allies, of course, never admitted its existence during the war. For Germany, the gun became a shadow of obsession. Every intelligence report, every reconnaissance sortie, every intercepted message referenced it with fear. In the frozen fjords, in ruined harbors, and in abandoned bunkers, the knowledge lingered. A weapon Germany thought was fiction had become horrifyingly real. And in that moment, every German commander understood a harsh truth. The war was no longer just about men, ships, or planes. It was about knowledge, engineering, and the terrifying realization that some victories are won before a single shot is even fired.
By the summer of 1944, German engineers were desperate. Coastal bunkers near Kiel and Lübeck had become laboratories of obsession, where captured fragments of the Allied naval gun were scrutinized day and night. Every attempt to fire even a prototype ended in disaster. Barrels cracked, mounting systems buckled, and in one case, a small detonation destroyed a section of the testing facility. The weapon's design defied conventional logic. Its rifling maintained projectile stability over unprecedented distances, yet it lacked the recoil absorption system standard in German naval artillery. Instead, it appeared to use a combination of magnetic pulse assistance and advanced compression mechanics, a concept decades ahead of the 1940s. Metallurgists were equally confounded. The alloys used in the barrel and shell casings were lighter yet stronger than anything forged in German foundries. Attempts to replicate them produced brittle, unsafe results. By September, the Kriegsmarine High Command formally acknowledged that the weapon could not be countered with existing ships, torpedoes, or coastal batteries. Every reconnaissance and intelligence report confirmed the same terrifying reality. The Allies had achieved mastery over artillery that Germany could neither understand nor reproduce. Lieutenant Karl Hoffmann, now reassigned to oversee the reverse engineering project, kept a private journal. One entry read, "Every day we attempt to grasp the principles behind this weapon, yet it resists comprehension. It is as if it was built with foresight into physics we are only beginning to discover. As the months passed, rumors of the weapon's capabilities spread among German officers. Some claimed it could obliterate convoys from 30 kilometers away without warning. Others whispered the gun could disrupt radar and targeting systems with its electromagnetic discharge, effectively rendering German ships blind before the first shell landed. Fear permeated naval ranks. Commanders altered patrol routes, avoiding open waters where intelligence suggested the gun could strike. In October 1944, during a clandestine testing session, German engineers attempted to fire a reconstructed section of the breach with a captured shell. The experiment failed catastrophically. Sparks flew, instruments melted, and the bunker's reinforced walls trembled as though protesting the attempt. Hoffman later described the scene. "It screamed. I cannot describe it as fire or sound. It was a resonance that penetrated every bone in your body. We stepped back, terrified, and yet fascinated." Meanwhile, Allied intelligence continued their secret deployment. The weapon, fully operational, remained hidden under reinforced bunkers along the British coastline. German reconnaissance planes occasionally glimpsed its outline through aerial photography, but heavy camouflage and decoys prevented accurate assessment. Each sighting reinforced the belief that this was no ordinary artillery. It was a myth made real. By early 1945, with the war collapsing on multiple fronts, German efforts to replicate the weapon were abandoned. Scientists were reassigned to the V2 program, jet projects, and last-ditch engineering efforts. The fragments of the gun were shipped to secure bunkers in Bavaria, where they remained under armed guard. Yet Hoffman and a few surviving engineers carried the memory with them, haunted by the realization that technology had outpaced strategy. When Allied forces entered German territory in April 1945, they discovered the empty bunkers, partially dismantled artillery, and the remains of experimental shells. No complete weapon was recovered, only fragments, schematics, and cryptic notes describing forces and mechanisms that could not be replicated. American and British intelligence recognized the significance immediately. Analysts concluded that had the weapon been fully operational, it could have devastated naval operations in the North Sea, potentially altering supply routes and prolonging the conflict. The fragments that survived were transported across the Atlantic under the early phases of Operation Paperclip. Scientists at the U.S. Naval Research Laboratory examined them, noting the advanced metallurgy, electromagnetic components, and precision rifling. Reports describe the technology as decades ahead of current Allied designs. Even in the controlled environment of American labs, attempts to recreate the gun's full capabilities were only partially successful. Decades later, declassified documents reveal that principles derived from the captured fragments influenced post-war naval artillery, electromagnetic pulse research, and experimental propulsion systems. While the original weapon was never fully reconstructed, its legacy persisted in secret programs and classified projects, shaping naval engineering far beyond what German engineers could have imagined. Lieutenant Karl Hoffmann, in post-war interviews, reflected on the weapon with a mixture of awe and fear. "We faced a creation that should not have existed in our time. Every calculation, every model, every theory failed against it. We had only witnessed a glimpse of the future, a future we could neither command nor comprehend." The story of the naval gun Germany thought was fiction serves as a chilling reminder. Sometimes the most decisive victories in war are won not by numbers or bravery, but by knowledge and technology that surpasses imagination. A weapon unseen, a design misunderstood, and a power too advanced to be replicated, yet enough to instill terror in the hearts of those who encountered it. Even now, fragments stored in secure archives silently hum with potential, a testament to a device that changed the course of scientific understanding and military strategy forever.